In this video, we're going to look at ways in which we can describe single variable data, and we're going to also revise some of the diagrams that we can draw for single variable data. So, let's first of all think about some of the terms that we use to describe distributions. So let's suppose that we've got here a couple of bar charts or histograms, and these bar charts or histograms have got line of symmetry in the case of blue one and an approximate line of symmetry in the case of the red one. So the blue one we would certainly say was a symmetric distribution, and we'd probably say that the green distribution that we've got there is approximately symmetric. When we've got distributions which are symmetric, the mean and the median will be the same value, and if they're approximately symmetrical, then the mean and the median will be approximately equal. When we have a distribution like this one here, where there is a distinct tail of values going out to the right, in other words in the positive direction of the data, then we say that the distribution is positively skew. When we have a positively skew distribution, then the few values that we've got which are much bigger than the other values will have the effect of tending to distort the mean upwards. And that means that the mean will be larger than the median. Similarly, if we have a long tail going out to the left of a distribution, in other words in the negative direction, then it is described as being a negatively skewed distribution. And in such distributions, the mean value is going to be considerably less than the median value. If a distribution has just a single peak in its graph, then we call it a unimodal distribution. But if a distribution has got several peaks, then we call it a multimodal distribution. So, let's just have a look at an example. Here we have the prices in pounds of 100 laptops at an electrical superstore. The data was then grouped and represented by a histogram and a cumulative frequency diagram, as we will see in the following slides. So here is the histogram, and when we're dealing with a histogram, we can very quickly and easily make one or two conclusions about the data. Certainly this one is unimodal. We've only got one real peak in the frequency densities. And it's certainly not negatively skew. An argument I think can be put up in this case to say that the distribution is actually positively skew. So we would expect the mean for this set of data to be rather larger than the median for this set of data. When we're dealing with a histogram, we need to remember that the area of each bar gives the frequency for that particular group. So if we look at the group that goes from 700 to 900, we have a base of £200. The height of the bar is 0.135, so the area of that bar is 200 times by 0.135, which gives me 27. In other words, there are 27 computers between 700 and 900 pounds in the sample. The total area of the histogram gives us the area of the sample, and the area under part of the histogram will give us an estimate of the number of the observations in the sample between those two values. So, to work out the total area of the histogram, and thus to work out the total size of the sample, we need to do a calculation of the area underneath the histogram. So the first block has a base of 400 and a height of 0.02, so we've got 400 times 0.02 is 8. The second block we've already seen has got an area of 27. The third block has got a base of 200 again and a height of 0.065. So 200 times by 0.065 gives me 13. The next block has got a base of 200 and a height of 0.06. So that gives me 200 times 0.06, which is 12. For the next group, we've got a base of 200 and a height of 0.055. So that gives me 11. The next group, we've got a base of 300 and a height of 0.06. So the area is 300 times 0.06, which is 18. And the last group, we've got 500 times by 0.022, which is 11. So we can say that the total number of observations is the total area underneath the histogram, which is 8 plus 27 plus 13 plus 12 plus 11 plus 18 plus 11, which is 100. If instead we want to estimate how many of the laptops cost less than £800, then we need to find the area underneath the graph between 300 and 800. And we can do that by working out the two areas again. So the area of the first block is 400 times by 0.02. The area of the second block is 0.0135 times by 100, which is 13.5. So the area of the block is 8 plus 13.5. So we've got our estimate for the number of laptops which are less than £800 it's going to be somewhere around about 21 or 22 of the laptops. So here we now have a cumulative frequency diagram for the distribution of these 100 laptops. And we can use the cumulative frequency diagram very easily to find out the median, which is the cost of the middle laptop in the sample. So we've got 100 laptops altogether, so if we take the 50th one, the median then is somewhere around about £1,125. The lower quartile will be the price of the 25th laptop, which in this case is somewhere around about £825. And the upper quartile in this case is the price of the 75th laptop in the sample, which is somewhere around about £1,560. Now at GCSE you would have been finding at this stage the interquartile range. We'll be doing that later in this series of videos, and you might have drawn a box and whisker diagram. We will be drawing box and whisker diagrams in the future, but we're going to put a little bit more detail in those. So again, we're going to leave the box and whisker diagrams until later in the series of videos. Now often we just have discrete data which takes just a very few distinct values, and in that case a frequency bar chart is a sensible diagram to consider. So for the computers that we've just been considering, if we make a list of the RAM of each of the 100 laptops, and the RAM is measured in gigabytes, then we get the values shown in the table there. So this data can be summarized in a frequency bar chart, which we've got drawn here. And what I'd like you just to think before you finish this video off is how might you describe this distribution, and if one of these computers is chosen at random, what is the probability that the computer chosen is fitted with 32 gigabytes of RAM? So have a think about those two questions. When you've got answers for them, stop the video, we're done.